Volcano Chapter 2, The Big Blast. The May 18 eruption began with an earthquake that triggered an avalanche. At 8:32 a.m., instruments that were miles away registered a strong earthquake. The pilot and passengers of a small plane saw the north side of the mountain rippling and churning. Shaken by the quake, the bulge was tearing loose. It began to slide in a huge avalanche that carried along rock ripped from deep inside Mount St. Helens. The avalanche tore open the mountain. A scalding blast shot sideways out of the opening. It was a blast of steam from water heated by rising magma. Normally, water cannot be heated beyond its boiling point, which is 212 degrees Fahrenheit at sea level. At boiling point, water turns to a gas, which we call steam. But if water is kept under pressure, it can be heated far beyond its boiling point and still stay liquid. That is how a pressure cooker works. If the pressure is removed, this superheated water suddenly turns or flashes to steam. As steam, it takes up much more room. It expands. The sudden change to steam can cause an explosion. Before the eruption, Mount St. Helens was like a giant pressure cooker. The rock inside it held superheated water. The water stayed liquid because it was under great pressure, sealed in the mountain. When the mountain was torn open, the pressure was suddenly relieved. The superheated water flashed to steam, expanding violently. It shattered rock inside the mountain and exploded out the opening, traveling at speeds up to 200 miles an hour. The blast flattened whole forests of 180-foot-high firs. It snapped off or uprooted the trees, scattering the trunks as if they were straws. At first, this damage was puzzling. A wind of 200 miles an hour is not strong enough to level forests of giant trees. The explanation geologists later discovered was that the wind carried rocks ranging in size from grains of sand to blocks as big as cars. As the blast roared out of the volcano, it swept up and carried along the rock it had shattered. The result was what one geologist described as a stone wind. It was a wind of steam and rocks traveling at high speed. The rocks gave the blast its great force. Before it, trees snapped and fell. Their stumps looked as if they had been sandblasted. The wind of stone rushed on. It stripped bark and branches from trees and uprooted them, leveling 150 square miles of countryside. At the edge of this area, other trees were left standing, but the heat of the blast scorched and killed them. The stone wind was traveling so fast that it overtook and passed the avalanche. On its path was Spirit Lake, one of the most beautiful lakes in the Cascades. The blast stripped the trees from the slopes surrounding the lake and moved on. Meanwhile, the avalanche had hit a ridge and split. One part of it poured into Spirit Lake, adding a 180-foot layer of rock and dirt to the bottom of the lake. The slide of avalanche into the lake forced the water out. The water sloshed up the slopes, then fell back into the lake. With it came thousands of trees felled by the blast. The main part of the avalanche swept down the valley of the North Fork of the Turtle River. There, in the valley, most of the avalanche slowed and stopped. It covered 24 square miles and averaged 150 feet thick. The blast itself continued for 10 to 15 minutes, then stopped. Minutes later, Mount St. Helens began to erupt upwards. A dark column of ash and ground up rock rose miles into the sky. Wind blew the ash eastward, and lightning flashed in the ash cloud and started forest fires. In Yakima, Washington, some 80 miles away, the sky turned so dark that the street lights went on at noon. Ash fell like snow that would not melt. This eruption continued for 9 hours. Soon after noon, the color of the ash column changed. It became lighter, a sign that the volcano was now throwing out mostly new magma. Until then, much of the ash had been made of old rock. At the same time, the volcano began giving off huge flows of pumice and ash. The material was very hot, with temperatures of about 1,000 degrees Fahrenheit, and it traveled down the mountain at speeds of 100 miles an hour. The flow went on until 5:30 in the afternoon. They formed a wedge-shaped plain of pumice on the side of the mountain. 2 weeks later, temperatures in the pumice were still 780 degrees. Finally, there were the mud flows, which started when the heat from the blast melted ice and snow on the mountaintop. The water mixed with the ash, pumice, and ground-up rock and dirt and rocks of the avalanche. The result was a thick mixture that was like wet concrete, a mud flow. The mud flow traveled fast, scoring the landscape and sweeping down the slopes into the river valleys. Together, their speed and thickness did great damage. The largest mud flow was made of avalanche material from the valley of the North Fork of the Turtle River. It churned down the river valley, tearing out steel bridges, ripping houses apart, picking up boulders, and trucks and carrying them along. Miles away, it choked the Quartz River and blocked shipping channels in the Columbia River. When the sun rose on May 19, it showed a greatly changed St. Helens. The mountain was 1,300 feet shorter than it had been the morning before. Most of the old top had slid down the mountain in the avalanche. The rest had erupted out as shattered rock. Geologists later figured out the volcano had lost 3/4 of a cubic mile of old rock. The north side of the mountain had changed from a green and lovely slope to a fan-shaped wasteland. At the top of Mount St. Helens was a big new crater with the shape of a horseshoe. Inside the crater was the vent, the opening through which rock and gases erupted from time to time over the next few years. In 1980, St. Helens erupted 6 more times. Most of these eruptions were explosive. Ash soared into the air. Pumice swept down the north side of the mountain. In the eruptions of June and August, thick, pasty lava oozed out of the vents and built a dome. But both domes were destroyed by the next eruption. In October, the pattern changed. The explosions stopped, and thick lava built a dome that was not destroyed. Later, eruptions added to the dome, making it bigger and bigger. During this time, geologists were learning to read the clues found before eruptions. They learned to predict what St. Helens was going to do. The predictions helped to protect people who were on or near the mountain. Among these people were many natural scientists. They had come to look for survivors, for plants and animals that had lived through the eruption. They had come to look for colonizers, for plants and animals that would move in. Mount St. Helens had erupted many times before. Each time, life had returned. Now scientists would have a chance to see how it did. They would see how nature healed itself.